Welcome to Fluid Math. Fluid Math brings handwritten math to life. Fluid Math is a math teaching and learning tool for teachers and students in middle school and high school mathematics designed specifically for pen and touch computing environments like tablet PCs and interactive whiteboards. In Fluid Math, simple gestures can quickly produce graphs, tables, computations, animations, and more from your handwritten math expressions. Teachers like most that Fluid Math's user interface is handwritten math notation itself, which helps make the technology transparent, and that Fluid Math enables in a single tool a range of algebraic manipulations not available anywhere else. We trust that your students will find Fluid Math engaging and that you will find it an effective teaching tool. Let's look at a few examples, and we will start with simple arithmetic. You can write a simple arithmetic expression, for example 1 plus 2, and solve it. Using the scribble erase gesture, you can change the 1 to a 3 or a 4, and the result updates automatically. Note that in Fluid Math, you use a single arrow to simplify and a double arrow to get a numerical approximation, as in these two solutions for the fraction 3/6. You can also introduce symbols. For example, you can write a equals 1, b equals 2, and solve a plus b, or a minus b. Everything on the screen is dynamic, and when I change the 1 to a 2, the solution changes. I can also change the value assigned to b, and we can see the result change accordingly. One of the things teachers like most about Fluid Math is that you can move very fluidly between the three representations: the algebraic representation, the graphical representation, and the numeric or tabular representation. Y equals mx plus b is the equation of a straight line in slope-intercept form. With the graphing gesture, a simple swoop from the equation creates a graph in Fluid Math. The workspace in Fluid Math is dynamic. I can assign a value to m, and the graph changes accordingly. I can do the same for b. I can also create sliders with the slider gesture, a short vertical line written from the equal sign of an assignment. Sliders allow you to dynamically explore many values of a parameter. This is especially powerful for visual learners. Here we can see what slope means and how different values of m affect slope. Likewise, we can explore the y-intercept b. I like to plot the point 0, b on the graph before changing b because it really demonstrates the y-intercept. Fluid Math is a great tool for modeling, hypothesizing, reasoning, and bringing real-world examples into the classroom. Imagine that you are an algebra teacher and that you're teaching about linear equations and quadratic equations. You would probably bring a real-world example into the classroom to describe the math concepts. A good example to describe the linear equation would be the velocity of a car, which can be modeled with a linear equation. For example, driving at 80 miles per hour on the highway. You can also describe that a quadratic equation might model acceleration. We have two cars, A and B. Car A has a constant velocity modeled with a linear equation, a sub x equals 80 times t. The equation simply means that the location of car A along the x-axis is defined by 80 units of distance per unit time, 80 miles per hour. Car B is a police car which has to accelerate to catch car A. A quadratic equation will be used to model the motion of car B. B sub x equals 10t squared. In Fluid Math, we click the Run button and the cars move in an animated simulation as described by the math. That's fun and engages students in the same way it engaged you, but there is a math question. At what point does the police car overtake the speeding car? The algebra teacher will answer this by using a graph to help draw a hypothesis. The graph shows the cars meet at 8 units of time and about 650 units of distance. We reset the simulation to run for 8 seconds, rerun the simulation, and the cars appear to stop at the same location. But we have to be exact. So let's prove this. In algebra, we use substitution to prove things. So we substitute t equals 8 and see that the location of car A and car B are 640 when t is equal to 8, proving our hypothesis. I have just scratched the surface of what you can do with Fluid Math and tablet PCs or interactive whiteboards. I hope you enjoyed this video, and I hope you will enjoy teaching and learning using Fluid Math.